Hello everyone, and welcome to our session, Unlock the Full Potential of Your Game with Vulkan and ADPF. A few quick housekeeping notes. You should get a link to a feedback form. We'd really appreciate your feedback, so please fill that out for us. And we'd also love to talk to you about everything we're discussing here in this session. We're not going to do a live Q&A, but we do have a booth outside, and you'll be able to find us there or other people from Google there that'd be more than happy to discuss any questions you have about our topics today. To introduce myself, my name is Nate Drost. I'm a developer relations engineer working on Android games at Google. And I'll be starting us off. You'll also be hearing from a few other presenters in the session, and I'll let them introduce themselves as we move along. Our topics in this session are two technologies crucial to modern Android game development: the Vulkan Graphics API and the Adaptive Performance Framework, or ADPF for short, APIs. Today we'll be discussing the current state of these technologies on Android and where they'll be headed in the near future. We'll then take a deeper dive into how developers are taking advantage of Vulkan and ADPF in their games. We'll be hearing about how Krafton and Samsung collaborated to bring hardware-accelerated ray tracing to dark and darker mobile, and also how Netmarble used ADPF to optimize Game of Thrones' King's Road. To understand why these technologies are so important, I think it's helpful to understand just how far Android mobile development and Android device hardware has come in the past 17 years. Because when we compare the system-on-chip specs between the very first Android phone and that of a 2025 flagship device, the difference in capability is astonishing. On the CPU side, we've gone from a single 32-bit core running at around 500 megahertz to 6 to 8 64-bit core types with a mixture of big, little, and medium cores, some of which can peak at over 4 gigahertz. And on the GPU side, the difference is, if anything, even more dramatic, going from a limited fixed-function GPU to a programmable GPU with multiple execution units that are capable of performing something on the order of 1,000 to 2,000 times more mathematical calculations per second than that first Android device. So we've had these great advances in the hardware available to Android, and Android has had to make changes from the software side to take advantage of these new capabilities. And that's really where Vulkan and ADPF come into the picture. Today we'll be starting by looking at Vulkan. Compared to the older OpenGL-ES, or GLES as I'll be referring to it through this talk, API, Vulkan offers increased efficiency, is designed more closely to match modern hardware paradigms, and supports new features of advanced GPUs that simply aren't available through GLES. Vulkan was first introduced back in Android 7, but at that time it was really just an additional graphics API option. The Android operating system itself was still using GLES for system graphics. So while select games were using Vulkan, everything else on Android was built on top of GLES. And we can see that in this simplified diagram of the original Android graphics stack. Now today, Android is transitioning to Vulkan as the primary graphics API of the operating system. This was necessary to fully unlock the capabilities of modern hardware and not be constrained by the inefficiencies and frozen feature set of GLES. Zooming out a bit in this diagram, we can see that ultimately everything graphical in Android is going to be built on a Vulkan foundation. This includes not just the system UI rendering, but WebGPU, a new high-level graphics and compute API, which is now a recommended API for traditional Android applications, and also for web applications running in Chrome. And as we'll discuss later, for new devices in the future, GLES itself will be implemented on top of Vulkan using the Angle library. So what does Vulkan support look like in the Android ecosystem today? Vulkan support has been required for new Android, 64-bit Android devices since Android 10. And when we look at the whole picture of currently active Android devices talking to the Play Store, 89% of them support Vulkan. And that includes Android devices going all the way back to Android 7. So we've reached the point on Android where we strongly recommend Vulkan as your first choice graphics API for games. The most popular commercial and open source game engines have embraced Vulkan on Android and can help your game take advantage of the benefits of Vulkan. Depending on your device target list, you may want to continue to support GLES in older devices. But for many developers in new games, depending on your device list, it may make sense to go Vulkan only. As one real-world example of this, I'd like to share the results of a recent collaboration Google did with Unity. Unity is a tremendously popular engine on Android, and its Vulkan support helps Unity developers get the most performance out of the hardware that they're running on. We should have a video here, yes. Unity took one of their existing engine demos, Mega City Metro, and modified it to facilitate side-by-side comparisons between GLES and Vulkan on popular Android hardware. In this case, Unity benchmarked on a Pixel 7 Pro and a Samsung Galaxy S22. When we compare Mega City Metro running on Vulkan versus GLES on the same device, we can see a couple immediate benefits of Vulkan. Vulkan consumes less CPU time and thus power and is able to run for a longer period of time at a target frame rate before reaching that thermal throttling behavior for heat buildup on the device. For Mega City Metro, Vulkan is also able to achieve a slightly higher average frame rate than GLES, as rendering that world scene geometry can become CPU bound, and Vulkan is more efficient. Additionally, when taking advantage of Unity's dynamic resolution feature, which requires Vulkan and isn't supported on GLES, Mega City Metro can run at an even higher sustained frame rate on Vulkan, with a modest trade-off against visual fidelity due to the upscaling algorithm. Apologies, it may be a little challenging to see some of the graph data from this slide, but we can see an example of that increased efficiency and frame rate stability on a Pixel phone. At a 40 frame per second target, Vulkan takes longer to heat the device to the point where thermal throttling becomes an issue and is better able to sustain that 40 frame per second target. In this chart, we can see the effects of enabling that dynamic resolution feature in Unity I referred to earlier, which is only supported under Vulkan. With dynamic resolution, you have the ability to trade off increased performance and frame rate stability against how aggressively you want to upscale the scene from a lower resolution. And the more aggressive the upscaling, the greater the power and GPU efficiency savings. As an example of what that scaling looks like, here we can see that if you really crank up to a higher scaling factor, it can become noticeable. But at modest settings, dynamic resolution offers clear performance wins while being relatively imperceptible, especially for scenes in motion. So all these improvements we're seeing in Mega City Metro are a combination of Vulkan's reduced overhead and Unity's renderer taking advantage of features in Vulkan that aren't available in GLES. Vulkan is already more efficient at processing draw calls than GLES, but on top of that, Unity is able to reduce the number of issued draw calls in Vulkan versus GLES. It can do this through a greater capacity to batch instances together per draw call. It does this through the use of shader storage buffer objects, which have larger maximum sizes for data than traditional uniform buffers. In this chart, both APIs render just shy of 2,700 instances of the air duct geometry. But Vulkan was able to consolidate those instances down to just 8 draw calls, compared to 151 draw calls for GLES. And as we saw earlier, another big performance win for Vulkan was from enabling that Unity dynamic resolution feature. This feature required Vulkan as it relies on memory aliasing support, which doesn't exist on GLES. This feature allows Unity to efficiently resize at runtime the size of its render targets without having to reallocate memory. We have a demo of this in our booth outside, and you'll see a slider which you can use to change the scale factor of the dynamic resolution upscaling live on the fly. So that's our Unity Vulkan demo for Android. You can get a copy of this project at the Unity Mega City Metro GitHub URL on screen in this demo/Vulkan branch. And as I mentioned, we also have this on display at our booth, along with some of the other games that we'll be talking about today, and I encourage you to visit and check them out. Now, the Android ecosystem is very large, and we've heard concerns from developers about older devices with obsolete drivers. And we want developers to feel confident about enabling Vulkan in their Unity games, which is why we've worked with Unity to help games choose the correct graphics API for a given device. Vulkan on newer devices, and falling back to GLES on older devices with older drivers. This feature, Device List Allow or Deny Vulkan API Usage, is built directly into Unity 6, and there's a link to the documentation page there. For developers still using Unity 2021 or 2022, Google has released the VK Quality plugin on GitHub, which offers similar functionality for your game. So today, Vulkan is widely available. It's well supported by popular game engines, offers clear performance and power benefits, and we recommend you use it as your first choice graphics API for games. Many of these engines now include advanced lighting and rasterization technologies that are beginning to support mobile hardware on Vulkan, but they aren't available on GLES. But what about the future? Android is committed to keeping Vulkan support current with the latest Vulkan API developments. Android 15 introduced a requirement for new 64-bit devices to support version 1.3 of the Vulkan API. In Android 16, we're adding platform support for the newly announced Vulkan 1.4, and we expect drivers for those devices to be rolling out shortly thereafter. We plan to make Vulkan 1.4 support a requirement for new Android devices in Android 17. And we've gotten significant developer feedback on concerns of the GPU feature fragmentation in the ecosystem. Now, we can't change the hardware that's already out in the world, but we are aggressively working to reduce this with each new Android release. Two steps we're taking to address feature fragmentation include those Vulkan API requirements for new devices that I just mentioned. We've also introduced something called Vulkan Profiles for Android. Android introduced the concept of Vulkan Profiles for Android, or VPA for short, with Android 15. And you can think of VPA as additional requirements for new Android device hardware above and beyond what is expected by the specifications of a given Vulkan API version. VPA builds on and is in addition to our previous Vulkan or Android baseline profiles for Vulkan. VPA profiles are essentially a formal way of specifying minimum hardware capability limits, required hardware features, formats, and Vulkan extensions that must be supported by device hardware. The full list of the requirements of a profile are available in the published files in the Kronos Vulkan Profiles repo on GitHub. They're just in JSON format. Now, as part of Vulkan becoming the Android platform graphics API, it is changing how GLES support will work on new devices in future versions of Android. Current devices will keep their existing native GLES graphics drivers, but in the future, new devices will implement GLES by using a library called Angle, which implements a conformant GLES implementation on top of Vulkan. Angle has been included as part of Android releases since Android 15, and you can test your games against Angle instead of the native GLES driver through options in the developer settings. For most games, the performance implications of Angle are minimal. In our testing, some games even run faster on Angle than native drivers. But for new games, you will be better off targeting Vulkan directly, rather than layering through Angle on GLES. We're strongly encouraging developers to test an Angle on Android 16 and report issues, as we're continuing to maintain, iterate, and improve Angle as we prepare for it to become the system GLES driver for future devices. So to wrap up my section of this talk, Vulkan is widely available and well supported by game engines. Vulkan has clear performance and power benefits for your game and can offer advanced features that simply aren't available on GLES. We're tackling the device feature fragmentation problem through Vulkan API requirements and the Vulkan profiles for Android. We have allowed us situations like VK Quality and built-in Unity 6 functionality that let you target the right API for your game Vulkan on newer devices, less on older devices. GLESS isn't going anywhere, and existing devices will retain their current native drivers, but future Android devices will implement GLESS on top of Vulkan using Angle. And finally, I'd like to highlight our site for Android game developers, developer.android.com/games. You'll find a wealth of resources for Android game development, including Vulkan, ADPF, and other things. And with that, thanks for listening to my section. Now I'll hand over to our next speaker, Jung-Woo Kim from Samsung.
Thank you, Nate. I'm Jung Kim from Samsung, working in the Samsung MX, the mobile division, about GPU and DevTech. The DevTech team is to support the game developer, to helping them to using that cutting-edge technology like Vulkan and ray tracing, and also they figured out all kind of complicated issues related with the GPU and other hardware side thing. And also we support them to customizing their engines, so on. So I now here to say about what we are now doing jointly working between Google and Samsung about the gaming area. So, sorry. This is not the first time, and the history of Google-Samsung partnership in gaming area is long ago. So we had a really great joint work for launching the first Vulkan Android phone, Galaxy S7, and also we also worked together to developing the cool Vulkan demo, the Protostar, based on Unreal Engine. And also we do announcing the high-fidelity Android game program to support the game developer based on Vulkan support. And also at the same time, we do the foldable Android game experiences better. And also the GPU driver updatability for AGI tool support. It happened during recent 10 years, and even we are trying to keep push ourselves to how to do more even from now. During all the effort we made, the Vulkan was the key of Android's graphics and gaming. Vulkan can help you to boost your performance of your application and game, and also that help the developer to unify because the options are sometimes not give you the convenience or easy to deal with the selection of API. But if we just unifying with the Vulkan, then that help. You can waste your time to manage your resources to support the multiple APIs. And also that Vulkan help vendors focusing on one single Vulkan GPU driver and forget about the GLES, and also the massive hack on that. And also that help us to expand the capability of our application and also visual fidelity of our game graphics better with more in advanced technology like ray tracing. So Vulkan is helping adoption of the new technology like ray tracing, and also that gives not only the frame per second improvement, but also that is a differentiation of your gaming graphics visual quality better. We do show that S25 Unpacked event, a ray tracing game, Diablo Immortal, with the bleach out and that is. You can see that ray traced reflection on the wall and ice cape. That gives your games a visual fidelity differentiate than other games, and that also the helping your customer expectation is higher. So not only that feature, but also still there's many kind of the Vulkan optimization necessary to developing the Android game. There's a bunch of things that listed right side of the slide that still there's many common misuse of Vulkan is there. Even that what you see in the Unreal Engine and Unity, like the commercial game engines, they're well known. And also the relax the pipeline barriers. Pipeline barriers is one of the tricky point of using Vulkan better or proper. And also render deferred surpass optimization, and also the rage acquire and render pass optimization and specialization constant that gives you a more efficient way of handle the conditional shader behavior different. And also pending render passes and pending texture load. All those kind of optimization skills we have, and also we helping the developer can use to fix their game engines work proper and also better with Vulkan API. This gives a kind of the practical uplift of your game running faster, and also sometimes that with the same performance, lower workload. We apply that all the optimizations into the Docker and Docker Mobile, and then give that optimization is the helping the games running relevant to 20% lower GPU workload. That is giving help to the lower temperature, where sometimes that gives a better frame per second. And also that also can give some margin of apply new technology like ray tracing. Thank you, Crafton and Bluehole, to give opportunity to we can apply those kind of all the optimization we made, and also apply that new technology ray tracing. So even the Galaxy flagship recently is growing fast at ray tracing performance highly. Annually, 50% uplifting is now continuously happening in recent 3 years. But ray tracing is still really complicated process. So we did a tight reduction of the cost of every part of it. So we redesigned all the ray tracing pipeline to implement the shadow and also reflection. And based on that redesigned pipeline, is not enough to handle all the things because the GPU load is so high. So we did adding the multiple optimization technique into the reduce the GPU load lower. And it gives a kind of, sometimes the 5 or 10% off-roading, sometimes the 40 or 50% off-roading. All the detailed optimization we made for the Vulkan and ray tracing will be covered our own Samsung session in this room today at 12:30 p.m. And please come and see what the details. Our colleagues will cover all the things. So based on this redesign the pipeline and also the all implementation and optimization we made, we applied this to the Docker and Docker Mobile. And you see on ray tracing reflection around the water surfaces, that is realistic and also the visually beautiful. And also in the case of the shadow is the ray tracing that is more accurate and also the really visually beautiful. But the Docker and Docker Mobile is apply this all shadow and reflection with ray tracing processing. That is taking just the 15 or 20% GPU workload more. That is only you need to apply those effects. Anyway, that the wide and rich developer relationship is the window of this kind of the joint work, and also helping the adoption of this technology like ray tracing and Vulkan into more wide range of Android developers. So Samsung is continue to this work with Google and also all other game development engine companies to helping all Android game ecosystem better. Now I will hand over to Do-hyun.
All right, let's switch gear and talk about something incredible important for certain game performance, the Adaptive Performance Framework, or ADPF. Think of it as your secret weapon for deliver consistent, smooth, and enjoyable experience on Android device. It's not just about the hitching peak performance. It's about the maintaining, even when things get heated, literally. ADPF uses smart technology to deliver the best experience based on the summer of the phone. I'm Doyeon Kim, and a developer relation engineer at Google. I spend my days deep dive into the game performance, especially the Vulkan and the ADPF. Okay, so what is the ADPF really? It's fundamentally about the proactive managing performance based on the two core APIs. The Summer API. This gives you real-time insight into the device temperature. You can then intelligently adjust your game workload, such as the resolution, frame rate, or some visual effect, to prevent overheating and throttling. It's all about being proactive. The Performance Hint API. This is where you talk back to the system. You provide a hint about your game workload. For example, is your game is CPU or GPU bound? It's more important to maintain a constant frame rate or to push for the absolute highest visual fidelity. The system uses this information to optimize the scheduling and power management specifically in your game. In short, we get information from the device with the Summer API, and we provide the guidance to the device with the Performance Hint API. Two-way street. Let's dive into more about the Summer API. We actually give you two ways to tap into the summer state on the device. Get summer headroom. This is where things get interesting. This API gives you a floating point value that represents the device temperature headroom. A value over the 1.0, a warning signal, throttling likely. Or even value like the 1.7 suggests that summer throttling could be on the horizon. It allows us to catch some throttling before it happens. We recommend pulling the get summer headroom at least every 10 seconds. That gives you a good balance between the responsibility and avoiding the unnecessary overhead. Pulling too frequently can actually lead to incorrect value or some name value, because of the device itself doesn't need to update the summer information very often. Add Summer Headroom Listener, available from the Android 16. This is the great addition to the Summer API toolkit, allowing the developer to proactively monitor Summer Headroom changes. This function let the device is changed. This new API is very useful for the games that you want to be precious, proactive summer change. To help you make an intelligent decision based on the summer headroom, the Summer API also offers get summer headroom threshold. This function returns a map that links the specific summer headroom value to their corresponding the summer state level on the specific device. For example, in a Pixel 9, a headroom value above the 1.0 might indicate severe summer state. Remember that these thresholds are device-specific, and you can change it even after OEM device testing. This API returns the correct value for the device for the game on running. The key takeaway: use the get summer headroom threshold to proactively tailor your game performance based on the device-specific the summer. Now, then you have a good understanding of the Summer API, let's explore the Performance Hint API. People under 15, well, yeah, let's just say that it's simpler and less effective. you essentially had a two API. Update target walk duration. You'd use this API to tell the system how long you intend each frame to tag. For example, if you were targeting 60 FPS, you set the target around the 60 milliseconds. Actually, you don't need to report the target duration every frame. It is okay to report when the target duration is changed. Report actual walk duration. Then you report the actual time it took the rendered frame. For example, let's say you set the target duration to 60 milliseconds, which is the 60 FPS, but the frame actually took the 20 milliseconds to render. The system might then try to schedule tasks on the bigger core or boost CPU frequency to have you hit the target. However, the problem with this approach was that it not only provide a single aggressive duration. The system had no idea where the bottleneck was. Was it the CPU or GPU? So its availability to optimize was pretty limited. Thankfully, from the Android 15, changed all that. From the Android 15, bring a massive upgrade the performance hint API. We've moved from the menu single number to the much more the granular and intelligent system. Now, instead of the report single duration, we use the report walk duration with the walk duration object. And this walk duration object gives you more power to specify the separate duration, CPU and GPU walk. Think about the more implicated. The system can now intelligently determine whether your game is CPU or GPU bound. If the GPU is toggling, it can prioritize the CPU frequency. If the CPU is the bottleneck, it can adjust the CPU scheduling in much more target approach. Plus, we've added the set prepare power efficient method. This allows you to tell the system that you prioritize the power efficient over absolute peak the performance. So if you're already running cool, you can tell the system, hey, don't push things too hard. Let's aim the more sustained experience, such like that. It is all about finding the right balance. Okay, enough the theory. Let's see the ADPF in action. We've created a new Vulkan sample that really highlights the benefit of the ADPF framework as well. One of our goals is to make the ADPF as accessible as possible. That's why we've tightly integrated it into the Unity engine through the adaptive performance package. This package gives you a clean, high-level interface for adjusting graphics setting based on the summer. The Android provider component is your key to the ADPF integration. It handles all the low-end stuff, the getting summer headroom data, report performance hint, and the talking to the Android system. This means you can take advantage of ADPF without having written a ton of framework-specific work. It's designed to simple and efficiently. All right, let's talk about the result. This is where the number of meat on the road. Let's dive into what ADPF did for your Android Vulkan sample on Pixel 7 and 9. Look at the Pixel 7 result. Without the ADPF, the game was toggling. Average just 27 FPS and unable to maintain smooth 60 FPS. But with ADPF enabled, we locked in the solid 60 FPS even after 10 minutes of the gameplay. It is 100% improvement, pushing the average to the 56 FPS. And crucially, the device ran significantly cooler, showing the dramatically increased the summer headroom. Now, even more powerful in the Pixel 9, which start at the higher 45 FPS, we saw frustrated frame drop. ADPF eliminates this drop entirely, delivering constant smooth 60 FPS result and improve the summer headroom. With the average FPS at 58, it is the 27% improvement. ADPF dramatically improved both sustained performance and the summer, deliver consistent, better gaming experience. No matter the device, that's a game changer. Now, in a caution, while ADPF is powerful, it's critical to configure incorrectly, particularly when it comes to graphic quality setting. In this video, you are seeing the Unity sample running in the Pixel 7 after heat up. Do you recognize what is the problem? Yes, the building is there disappearing. That's because of the Unity update performance package was configured with the too aggressive view distance reduction. The key takeaway here is that you need to carefully define the acceptable range of the graphic quality setting for your game. You want to avoid the situation where the game becomes visual unappealing due to the override aggressive ADPF setting. Let's move on to the real world. So we've seen the demo how the ADPF can work, but how does it translate in actual game-sipping game? Well, Netmarble integrate the ADPF in their game, Game of Thrones: The King's Road. Let's learn how they do it. Game of Thrones: King's Road is an action-adventure RPG based on the Emmy Award-winning and the Golden Globe-winning Game of Thrones series, developed by the Netmarble and official licensed by the Warner Bros. Interactive entertain on behalf of the HBO. The game brings the world and characters of the original series. Explore familiar location from the TV series, face on the horror beyond the wall, and rebuild your house into the hushed Northland. Become a true survivor Westeros and undead but brutal bandits or gluttonous nobles. The game also features multiplayer content where you can team up with the other players to tackle mystery creatures brought to life. In a game for the first time in an original and capital way. If you have the longer explore Western firsthand and experience new story, discover Game of Thrones King's Road in this video.
Castle Black is the only thing standing between the White Walkers and the Seven Kingdoms. Someone must gather the support of the Great Houses. We could use your help. You've seen the White Walkers yourself. You know what they can do. They have to be stopped. Like it or not, winter is coming.
Cool. Netmarble took a smart data-driven approach. They analyzed the performance impact every graphic quality setting in their game. And they uncovered the key insight. Resolution scale had the most significant impact on GPU load without a dramatic drop in the frame rate. Now, why is that so important? Because of the reduced GPU load, directed trends to the lower heat generation and improve the thermal performance. In simple terms, by adjusting the resolution, they could significantly reduce the strain on the device without the scratch the much visual fidelity. Just look at the data. Dropping the resolution from the high to low resulted in the 23% decrease the GPU usage. This crucial discovery became the base of the entire ADPF strategy. And importantly, they confirmed that other graphic quality option had the minimum impact on the overall performance. This allowed them to focus their effort on the resolution scaling. Based on this finding, Netmarble created a targeted ADPF strategy. Dynamic adjust. They would dynamically adjust the resolution and the target FPS based on the device thermostat. Prioritize the visual quality. When the device was running cool, they maintained high resolution and maximum FPS such as 60, delivering the best possible visual experience. Control the reduction. As the device heat up, they would gradually reduce the resolution and potentially lower the target FPS. It is because the target frame rate depends on the game content. To avoid the thermal issue, they decide that the minimum scale FPS is to 30. The goal was to strike the balance, maintain the smooth, enjoyable gameplay experience while minimize the thermal issue. Smart. So, how did the Netmarble ADPF implement pay off? The result in the Samsung Galaxy S24 device are compelling. Let's break that down. Without the ADPF, after 15 minutes of the gameplay, the FPS is changing between the 40 to the 86. Notice inconstant? With the ADPF, while the average FPS is much lower due to the intelligent adjust, the experience is much smoother. Most importantly, they achieved a significant reduction in the thermal throttling. The thermal headroom value is never over the 1.0. The average thermal headroom is reduced from the 1.04 to 0.92, which 11% reduction. That's the ensure long and the constant gameplay. This translates directly into the game reliable, enjoyable, and constant experience of the Game of Thrones King's Road players. Based on our experience and the Game of Thrones case study, there is some key suggestion for the integrate the ADPF in your game. Analyze. Carefully evaluate the performance impact to different graphic quality settings. Don't assume the reducing shadow will have some same effect reduced texture resolution. Define your floor. Determine the minimum acceptable graphic quality level. Consider what to adjust. You may adjust the graphic quality level, target FPS, or even game difficulty level based on the thermostat. Give player control. Create an adaptive graphic quality option in your game setting. This allows the game player to choose between the prioritized performance or visual fidelity. Test your ADPF implementation thoroughly on wide range of device. Smooth transition. Avoid the sudden joggle change to graphics setting. Gradually adjust as less noticeable and more present to game player. The ADPF ecosystem is growing fast. we are collaborating close with a lot of the leading game companies and OEMs, like you see in the slide, to improve the its fundamental and adoption. It's because there are a lot of the difference of a device with a different firmware that can be optimized to provide the best game experience. We provide the direct support to the partners to integrate ADPF in the games to achieve the best result. So please integrate the ADPF, we fully support over that. Now, the ADPF is very convenient to use if your game is using the Unity or Unreal Engine or Cocos. You can easily integrate the ADPF into your game. In your game is based on the Unity, Adobe Performance provides the graphic quality scaler based on the summer from the Unity 2021.3. If your game is based on the Unreal Engine, Google provides the ADPF plugin that are available on the GitHub. Please use the plugin and test it. If your game is based on the Cocos, ADPF already implemented in the engine from version 3.8.2. So let's recap. The ADPF performance framework is your key to unlock the sustained performance and deliver a better experience on the Android. It gives you an essential tool, the Summary API to monitor device heat in real, and Performance Hint API to tell the system about your game workload to optimize resource allocation. By combining these two APIs, you can optimize your game a wide range of devices. I recommend to check the more detailed information such as API integration and case study in this page. Thank you so much for your time and attending. I hope you found this presentation information and inspiring. I also want to encourage you to check out the other Google and the Samsung session at the GDC. The Vulkan and ADPF and multi-platform are actually on the Google booth demo on the second floor. Please try to visit the Google demo as well. Thank you for attending. Yeah.